what I'm going to explain to you is going to seem complicated, but if you make the effort to learn this, it would really help us moving forward. Okay, so if I have A equals B and C equals D, I can write some new statements that will also be true. Okay, so if A equals B, I know that A and B are the same. So if anywhere where I write A, I can also say, I could have also written B here, okay? Then I say, okay, to A, I'm going to add C. So if I add C to A, add C here. Now this could have been, instead of A, I could have had a B, and instead of C, I could have had a D. So this is actually the same as B add D, okay? And I can write that on this side. Now, using this idea, we can solve what we call simultaneous equations. Okay, so here what we've got is two equations, and I've got, two equations with different variables here. And if I know this idea that I'm going to add these bits of the first equation, and remember, these are equal to the other side, so adding this would be the same. Okay, if I was to take away, I could do that as well. So I could say A take away C is equal to B take away D, okay? I could also have said A add D equals some things here, okay? How about we say D take away B, what would that be, okay? I want you to copy this out, and I want you to fill in what goes in these spaces here. What I have now is a problem that I can solve using this idea. Okay, so I have two equations. Can you see I've got four sides to the equation? So I've got one thing here equals a second thing there. Then I have a third thing here equals to a fourth thing here. So like we had A, B, C, and D, I've got A, all of this is A, this is B, this is C, and this is D. Okay, I can think of it like that. Now, remember, these are also true if this was true. So I can apply these ideas to this. So A and C are in these positions, okay? So I've got 2A plus 4B and 3A take away 4B. These are in the positions of A and C. If I add them, and I also add B and D, so that's 18 and 7, on the other side, I might be able to solve it. So let's see what happens when I do that. So if I add 2A, add 4B. Now I need to add to that all of 3A take away 4B, okay? And this is going to be equal to 18 add 7. Let's see what happens. So 2A add 4B add 3A. So 2A and 3A added together is 5A. And then 4B add a negative 4B is just 0. So this just goes away. So I've got 5A on this side. 18 add 7 is 25 on the other side of the equal sign. Okay? And now 5A equals 25. Now if I divide by 5, I will get A. I need to do the same here, divide by 5. So A equals 25 divided by 5, which is 5. Now if I know what A is in this question, so I can find what B is, because if A is 5, I can say, well, 2 times 5 is 10. So 10 add 4B is 18. So let's write that down here in a different color. So I've got 2A add 4B. So 4B equals 18. Well, A is 5, so I can say 2 times 5. I'm going to write it like this. Add 4B equals 18. Well, that's 10. So 10 add 4B is equal to 18. If I take away 10 here and take away 10 here, I will get 4B is equal to 18 take away 10 is 8. Divide by 4, divide by 4. I will get B is equal to 8 divided by 4 is 2. So in the end, what I get is A equals 5. So A equals 5 and B equals 2. That's true for this equation, and it's also true for this equation. Okay, so A equals 5 in both of these places, and B equals 2 in both of these places. I'm going to solve another pair of simultaneous equations now, okay, and this time I'm going to be taking away, okay, and I will show you what I mean by that, and then we will compare when we can add and when we can take away. So this time I'm going to do 5x plus 2y, take away 2x plus 2y, and on the other side of the equal sign, I need to do 26 take away 14. So let's write that down. So we've got 5x add 2y, take away all of 2x add 2y is equal to 26 take away 14. Now, 5x take away 2x will give me 3x, so I can write that down. I could also think about expanding this bracket, so negative multiplies to this, negative also multiplies to this bit here. The other one is add 2y and then take away a positive 2y. So I've got positive 2y, take away a positive 2y, so that's going to be 0, so this will no longer be there. And then on this side I will get 26 take away 14, so that's 12. So that's going to be equal to 12. Now notice how at this stage I am only left with one variable, and it was the same in our other example as well. So if we take away here, the y's cancel out and I'm left with only something with x. And in the other example, if I added, I cancel out one of the variables and I'm left with one variable. Okay, when I have one variable, I can solve this quite easily. So divide by 3, divide by 3, and divide by 3. I will get x is equal to 4. Now, when I know x is equal to 4, I can use either one of these equations to find the value of y. Let's use the second one because this one has smaller numbers. It might be easier. So if I write this one, let's do it in a different color again. So 2x add 2y equals 14. So x is 4, so I can write 2 times 4 add 2y equals 14. 2 times 4 is 8. So 8 add 2y equals 14. Take away 8, take away 8. 2y is equal to 6. And then divide by 2 and divide by 2. I will get y is equal to 3. Okay, so for these simultaneous equations, x is equal to 4 and y is equal to 3. Now, I want you to think about this example in a different way. Okay, so x and y can represent the cost of two different items in a shop. So, for example, x can represent the cost of a particular sweet, and y can represent the cost of a packet of crisps or something. Okay, I've got 5 lots of the sweets plus 2 lots of the crisps, and that gives me a total of 26. Okay, in this one I've got 2 lots of the sweet and 2 lots of the crisps, and that gives me a total of 14. Now, if I subtract these, what I do is I end up subtracting. So if I look at the difference between the two, that will be subtracting. So I end up subtracting the 2 packets of crisps and the cost of them. And the cost of them will subtract from here as well. And I also subtract the cost of 2 sweets from here and here. And I'm left with the cost of 3 sweets. So 3 sweets cost 12 here. Okay? And then if I divide by 3, I get the cost of 1 sweet. Okay? Think about that example because that can help you understand how to do these problems as well. So now I want to compare these, okay? So I said I was going to compare them and why we added once and then subtracted the other time, okay? Now, if you look at these equations here, you can see that I've got a positive 4b and a takeaway 4b. And it's kind of the same magnitude here, so 4 and 4, okay? If I can add these will cancel out, okay? So if I add these equations in that way, this will cancel out. I will get 5a here, and I will get 25 here. If you look at this one, I've got positive 2y and positive 2y. In this case, I need to subtract them to cancel this bit out. And if I subtract this as well, I'll get 3x here. If I subtract this, I will get 12 here. And the y's will go, and I will be left with 3x equals 12, and then I can solve from there. So the way we choose to add or take away really depends on what we have here, okay, and what we need to do in order to cancel out one of the variables. Now, we could also get, for example, plus 4b and then take away 7b. So 2a plus 4b, 3a take away 7b, an equation like that. Now, with those equations, it wouldn't matter if I added or subtracted, they won't cancel out. So we will need to look at multiples of those equations to do them, and we will do that later. Now here are some for you to try. Okay, so the first couple of examples, they are similar to the ones that we've done, but then they change a little. Okay, so you think about how you're going to either add the equations or subtract the equations to eliminate one of the variables so that you can solve them. Okay, so have a go at that. These three here are slightly different looking, but we need to be able to do all different variations, and I need you to have a go first.